Alright, question 9, let's go. So this is asking us, where is the electric field strength equal to 0? Okay, so what formulas are we allowed to use here? We're allowed to use the E equals KQ over R squared formula. And the reason that we're allowed to use that formula is because these are point charges. Alright, so we need to do the vector sum of these two things, okay, and if the vector sum comes to 0, then we'll have found the answer, right? So I'm going to make a guess. I'm going to guess that it's at D, all right, and that I'm going to call a distance R, and that I'm going to call a distance R. They look about the same. Okay, so the total distance from D to 4Q is going to be 2R, right? All right, let's work it out then, right? So we've got the E from the plus 4Q charge, so that's K4Q over 2R all squared. And then we're going to add that to the K, and now it's going to be minus Q, okay, over R squared, okay? All right. And if you work all of that, that's going to cancel with that, and yep, and it basically, all of that cancels out, and it's going to end up as 0. So we found our answer, it was in fact D, okay? Is there another way that we can do this that will get us to the answer a bit quicker? All right. If you put a test charge over here, right? Let's put our test charge here. What's going to happen? It's going to be repelled strongly by this, and it's going to be attracted weakly to this. So which one's going to win? This one's going to win. And anywhere that we put our test charge over on the left, always, you know, this large charge here is closer to us, okay, than this weaker charge over here, right? So it definitely can't be A and B. That just doesn't make, that's not going to work. Okay. Similar argument, if you put your test charge equidistant between these two, okay, then the larger charge is going to win out, and it's going to repel it in that direction. So C's no good either. So by a complicated process of elimination, it must be D. Okay, and then if you think about D, okay, our test charge is getting attracted to this Q here, this minus Q here, okay, but it's getting repelled by the 4Q. But because the 4Q is further away, okay, then it turns out that the forces of attraction and repulsion are exactly balanced out with each other, okay? So you didn't need to do it algebraically, you could just look at it and think it through.